We have four very well-known panelists in this topic. I'll introduce them one at a time. I think we'd like to talk about the great changes that are happening in mobility during our lifetime. We're going to see a change that's probably as large as the change from horses to automobiles, and how that affects all of us and our children and society as a whole is the topic that we'd like to talk about today. So I'm joined here on my left by Ilya Komanovsky. If I could have the next slide, please. The next one, please. There's some information about Ilya here. He's the full professor in the Department of Aerospace and Engineering at the University of Michigan, where also he received his PhD. And in between, he spent 15 years in Ford research and advanced engineering. So Professor Komanovsky's research interests include applications of control to estimation and diagnostics to aerospace and automotive systems and spacecraft control, propulsion systems, and optimal energy management. And he has a long list of awards and prizes that you can read about in the program, but I won't mention now. I'll go on to introduce Sertaj Karaman, who is actually I had the pleasure today of introducing Sertaj to Stark Draper, who's in the audience perhaps someplace, the grandchild of Charles Stark Draper. And Sertaj actually corrected me. He was just promoted to associate professor of aeronautics and astronautics at MIT. He received a PhD in electrical engineering at MIT. And his research interests lie in the broad areas of robotics and control theory and application areas including driverless cars, unmanned aerial vehicles, distributed aerial surveillance systems, air traffic control, certification and verification of control system software, and many other things. Next to him is Umit Ogunzar. He's at Ohio State University. He's the TRC chair in ITS, electrical and computer engineering. He also directs the OSU Crash Imminent Safety University Transportation Center. He received his PhD from the University of Illinois and has also worked at IBM in Yorktown Heights and in Istanbul Technical University. He is an IEEE fellow. Professor Ogunzar's research interests are in large-scale systems, decentralized control, intelligent transportation systems, and autonomous vehicles. And finally, we have Ed Olson, also from the University of Michigan, where he's an associate professor in the computer science and engineering. And he also leads the April Robots Lab. And recently, he's become the leader of the perception area in the Toyota Research Institute. He received his PhD from MIT, and his interests include autonomy, perception, robotics, interfaces, and learning. And he currently has active research projects that include explosive ordnance disposal, search and rescue, multi-robot communication, railway safety, and automobile autonomy and safety. So in the next slide, I'll be coming back to these discussion points here, but I think the fundamental question is to ask, in 20 years, what will personal mobility be like? And so I think maybe we could go through the panel first, just talking about that vision for the next 20 years and providing any background information, and then we'll come back and hit some of the other bulleted questions as we go on. But first, I'd like to just know, what form will people of mobility will people be using regularly? Will it be private? Will it be shared? How will you deal with customization, personalization of transportation in the future? How will it differ around the world? You don't have to answer all of these questions, but any of these that you choose to. And what will be the infrastructure required to support that vision? So maybe we'll go through this quickly, and then you can kind of state your general views, and then we'll come back and talk about some of the more detailed questions. So why don't we start with Ilya? And I think you have some slides to kind of start us out.
Yes, if I can have my first slide, maybe the next one. So there are several factors that drive mobility evolution, and I try to summarize them here. So the first one is energy and environment, traffic congestion, and reduction in travel time. That's been the second factor. The safety and reduction in number of accidents is clearly another one. There are also changing demographics. There's more people living in the cities, and more people live longer. And so all of these factors, I think, will be driving mobility evolution in the future. Going to the next slide. So 20 years is a relatively short time span. If you look at some of the key technologies, for instance, the automatic transmission or airbags, it has taken, respectively, I think, something in the order of 50 years to 25 years for the technology to be broadly adopted and become standard in the vehicles. So I kind of feel there are several opportunities. Some of them are shorter term and longer term, and I'm not necessarily specifying the time frame, but I think in the shorter term, improvement of driver assist functions in existing vehicles, cooperative accident avoidance, for example, at intersections, enhanced route planning and guidance, as well as transitioning to condition-based maintenance of vehicles. I think this type of developments are going to happen. Now, I think if you go a little bit longer term, I think vehicles capable of operating as automated vehicles when feasible, and this could be both commercial and passenger vehicles, are going to happen. As more people live in the cities, we may see some interesting vehicle types that emerge. Perhaps two-wheeled vehicles, gyro cars becoming widespread, vehicles that have perhaps some degree of modularity, so they can be integrated into larger vehicles on the fly or be carried by another vehicle could happen. Vehicle sharing is probably going to grow. There is demand for that. And finally, I think at the end, and this is probably beyond the 20 years, but we might see personal air vehicles becoming more common, and of course that depends to a degree on automated vehicle technology maturing. Next slide. Now, with respect to automated vehicle and autonomous vehicle, there are currently challenges facing their development. The automotive industry has traditionally been about low cost, high reliability, and had difficulty accommodating solutions that are complex. So from that perspective, how to assure robustness and reliability of similar to current production vehicles, how to assure safety, comfort, how to reduce cost, and how to manage complexity are some of the important problems in this domain. In my research group, we are currently doing some work on validation and verification of automated vehicles, focusing on approaches for optimal design of test scenarios and data inputs for testing. Next slide, please. We also do some work in the area of connected vehicles, and here's an example where we collect road anomaly data by multiple vehicles, aggregate the information on the cloud, and that information can be used in a number of different ways. Next slide. For instance, it can be used for comfort-based route planning. It is just one of the factors. There are others. And so the plots on the right show that if you are willing to compromise the trip time, you may be able to avoid more potholes. Next slide. We also do some work on safety-based route planning. And here we combine models based on historical accident data with real-time factors such as weather and traffic. And knowing that there will be a colleague on a panel from Ohio State, I decided to show a few routes near Columbus, Ohio. And this is for different driver preferences for safety versus speed, as well as for different weather and time of the day conditions. Next slide. Finally, we are looking at the game theoretic approaches, primarily for validation and verification of automated vehicles. We use hierarchical game theory framework, as well as reinforcement learning, basically to train vehicles and driver models as they would be interacting in traffic. Next slide. And so you can take an autonomous vehicle, of course, the model of it, put it in a simulation environment, and assess various metrics as it interacts with other vehicles in traffic, such as violation of safe distance constraints, violation of comfort constraints, and so on and so forth. Next slide, and next slide. So this is the last slide which I want to finish this introductory discussion. People have been wrong in the past about what will happen in transportation. I happened to work on diesel engines, control of diesel engines for quite a few years, and Rudolf Diesel himself thought that diesel engines will be used to power sewing machines and wheelchairs, but didn't anticipate that they would be used to power big ships. And Harry Ricardo, one of the excellent engine developers, didn't think that police would allow diesel engine vehicles in the streets of London. Currently, the market share of diesels in Europe is about 50%, and surely some of them happen to be driving through London. So people can be wrong. With that, I finish my remarks.
Excellent. Maybe we could turn the slides back to the text slides of the 5 talking points ahead. So I'm trying to just get back to the bulleted list, but Sertaž, why don't you go ahead and talk about your vision of?
Yeah, sure. I mean, Ilya's comments were just right on spot. So I know we were supposed to be controversial, but it was kind of hard to disagree. So they were right on spot. I think there are like a few things maybe I can add and emphasize. One thing to add, I think, is that I'm not sure, maybe I'm too young, but I feel like, and I think many do, that it is a time for some transformation that may happen in transportation in the next maybe 10 years, 15 years. Mm-hmm. And this may parallel some of the big transformations that happened before. Like, for example, 150 years ago, it was when the trains picked up, really big growth. And 100 years ago, it was the affordable car that picked up with big growth. 50 years ago, it was the airliner. And then now it may be the time for not just an autonomous car, but could be a number of technologies coming together to enable something. This could be something that you may not guess. It could be the Hyperloop or something like that. Or it could be something like robotics, the shared economy, smartphones, high-speed internet connections, all come together to generate some sort of an urban mobility solution. And I think that would be something to, for example, think about and talk about probably. And this kind of a solution may be that in the past we've always talked about sort of going further, going faster, and it may be the first time that we may get a chance to think about, making it greener or making it more energy efficient or making it just enjoyable, just as a social acceptance point of view, which may also be interesting. Yet again, I know that I think we'll talk a lot about autonomous cars, and then not just here, but sort of I think a lot of people will be trying to build them as well, and it probably is the right thing to do. And there's another, like an interesting set of things that people can think about there. Right now, it's very hard to guess in which direction it's going to go, for example. It could be that a lot of places may try to put autonomous cars and just try it, even at the expense of safety, for example, just to try it. Or it may go on the other extreme and may become much like the aircraft industry, that, it's very, there's a lot of rules and putting things on the streets and everything has to be certified, where it turns into an industry which is, like in the aircraft industry today, building an aircraft takes like 25 years. You may join an aircraft in the beginning of your career and you kind of, retire and you've only worked on this one aircraft. So it may turn out to be something like that. So it's another, I think, interesting point to discuss to see where this whole thing will go. But I think it would be great to sort of take a step back and really think about what is happening today and what do we really need in terms of like a mobility solution. There's several that we need. One thing we could focus on could be like, for example, urban mobility. So what is really required in urban mobility? And there's many enablers, like Ilya also talked about, that many people are trying to move back to the cities. When you think about it, you would realize why they moved out. Like about 100 years ago, cities were disease-prone, they were dirty. Then the affordable car came in, and people realized you can actually move outside the city, and you can commute in. Then we start creating these suburbs, and people moved there. People actually started associating a good sort of standard of living with living in a suburb. Now it's kind of changing because cities are changing themselves. Cities are becoming places where it's actually clean, it's nice, there are parks. It actually enables innovation, it turns out. It's good to bring people into a city. And now we could look at all the technologies that we have, not just autonomy and cars and put them together, but all of the technologies that we have, and start to think about how do we enable a number of services that relate to mobility. And not just moving people either. For example, we can think about moving goods as well. It's actually pretty hard and energy hungry to move things around. People usually think about just ordering something from Amazon and it comes to you. But if you go to Manhattan 6 a.m. in the morning, you'll see several delivery trucks that are delivering stuff to small businesses. You go to a bar and get some dinner and it needs to come from somewhere. So kind of changing these things along the way, I think, is an opportunity there with a number of 21st century technologies converging and doing something nice and interesting. Mm-hmm. That would be mine.
Okay. 20 years, what will personal mobility like? I'm going to sort of talk about three different issues. And one, let's start off with a more controversial one, which would be in 20 years, let's say 20 years plus, will we have mobility? There is quite a chance that we may in fact be sitting at home in our little pod and not communicating. And if those of you who are interested in science fiction stories, there's a very good old science fiction story called The Machine Stops, I believe. I don't know if any of you have read it. It's over 50 years old, in which they imagine a life where you are sitting in your pod and just communicate even with your family that you have never met face to face. And everything is food and everything is delivered to the entrance of your pod. And we are slowly moving to have all the technologies, including the food delivery, mind you, which is an up-and-coming technology where you have a whole meal unprepared yet in little packages put in a box that's delivered to your doorstep. So you can even cook fresh food in your pod if you wish. So that's one thought that we have to truly consider. Is it going to happen or not? So leaving that one aside, I think we have sort of touched on various issues. Let me mention the recent trend on pushing for smart cities. The smart cities phenomena, which has been active and popular outside the U.S. and in Europe, has seemed to be taking off in the U.S. now, especially with the Department of Transportation pushing these smart cities, picking the 7 finalists, of which it's going to pick one. But it has come to a point where all the cities that have been looking into what we technologists think of more mundane things like the potholes and the type of asphalt are now suddenly into all the high-tech stuff and running their electrical vehicles, communicating vehicles, providing service to individuals. So that, I think, is going to have an effect. Whatever happens with the smart cities phenomena, there is now a multiple city in the U.S. type of trending towards including a lot of the technologies we are talking about for mobility. And more service will be brought to a wider range of people. There's a lot of work going on in first mile, last mile type of issues, where certain things come to a certain point, but not necessarily to your doorstep, and then there will be service provided to bring that mobility capability to your doorstep. So if you are elderly, and certainly the elderly are having an effect on this, there will be service provided, let's say, from your doorstep to the nearby bus stop or the nearby drugstore, and so on. Possibly slow, could be single person, two people type of mobility capabilities, and that certainly is going to continue more. I have been involved in autonomous vehicles for over 20 years now, and looking at it from 20 years ago to now, things have changed. Obviously, the technologies have increased, the wireless V2V connections, and the sensors have become cheaper. Wireless V2V, V2X has been become prevalent. And so it's getting to be harder to imagine what else can happen in 20 years, but obviously things will go on. One thing that has changed a lot is, of course, 20 years ago, we were thinking, almost all of us were thinking more that we'll have segregated lanes and segregated highways. I mean, automated highway systems, AHS was the trend before. And suddenly now think, yes, we can put those cars onto the city streets, and they will have a mixture of self-driving cars and human-driven cars. That is suddenly bringing a lot of other issues that will not be that quickly solved. Certainly having fully structured environments and that segregated lanes can provide you are not the way things seem to be going right now. At least there's a lot of activity in this mixed traffic thing, in which case we have to look at much more for this interaction with human beings, and the fact that human beings will be making decisions in their cars that, well, may be unpredictable or illegal, and our automated cars that are nice and go by the rules will have to be taught how to deal with these strange people also driving in the roadways. So a lot of things along those lines are going to happen.
All right, I'm going to err on the side of being a Luddite and a pessimist, just as a deliberate counterweight, perhaps. And the problem is that is the fault of a lot of people in this room, that the cars are just too darn reliable. The car 20 years from now will have the fleet of cars on the road will include the cars being manufactured today. And there's going to be a long transition period where we're going to have a huge mix of today's vehicles, which are barely autonomous or probably shouldn't be autonomous at all, and the capabilities will slowly ramp up. So we'll just be forced down this very slow transition of feathering from today's cars to future cars. 20 years is a pretty long time. I think the challenges for building a vehicle that can be fully autonomous, and by fully autonomous in this case I mean you put your kids in there and you tell the car to take the kids to school. That's a really hard problem, right? And when most of the time you see in the press people talking about autonomy, they're talking about some tiny subset of that, where maybe it's autonomous on the freeways or in some limited geo-fenced area. But maybe 20 years from now, we'll be talking about a vehicle that, honest to God, has no steering wheel. But that vehicle will have to coexist with all these older vehicles that are on the roadway. The dedicated lanes, I agree, this is just not happening, right? In the United States, we don't have the political or social will to invest in that. And so we're going to have to deal with that. And that's going to push the time frame out even farther for fully autonomous cars, because we're going to have to deal with the messy and the ugly situations that you talked about. One of the things that we like to say as people who build autonomous cars is that humans are terrible drivers. It's not true. Humans are amazing drivers. Humans drive 100 million miles per fatality. That is a lot of miles. and there are a lot of things that we can do to improve the performance of of an ADAS system, to improve an ADAS system that are going to have huge potential impacts, where we could make a driver in control of the vehicle drive an order of magnitude better than they do now, 1 billion miles per fatality. Even simple things like a forward collision mitigation braking, a $100 radar in the front reduces collisions by about 15% right there. Now, that's not all of it, but you add all these things up, and the bar for what an autonomous car is going to have to do is just going up and up and up. Meanwhile, the cars themselves are really bad at making autonomous decisions. One of my favorite examples is you're driving up to an intersection, and there's someone standing at the street corner 50 meters away from you. And what you do depends hugely on whether their eyes are up like this or down like this. Right? That cue by itself is a huge factor in how you treat that pedestrian. Now, if you get it wrong, does it mean a collision every time? Of course not. Right? It's only once in a blue moon when all of the bad things stack up at the same time that leads to the car hitting the pedestrian. But one fatality per 100 million miles gives you basically such a tiny little budget for making mistakes. And so I think it's going to take a long time for us to get there.
All right, thanks. I think we can now kind of enter into some of the other questions, but I'd like to also emphasize that we'd like to make it more interactive, so please, questions from the audience at any time. But in the meantime, we'll go on to the next question here, which is what technologies you see as required. Is that somebody's phoning in?
Is that me? No. It's not me. It just sounds like it's me.
I don't know.
It's
Okay.
Someone needs to go get their kids. All right.
Are you going to be?
Okay. All right.
Personal mobility in 20 years.
Send the autonomous car.
There's a question back there.
Oh, yes.
Depends on the definition of the future, maybe. But
So maybe I'll repeat the question for the recording here. He asked in the future whether you thought it was more likely to have autonomous taxis or personal autonomous vehicles coming. I mean, we've heard both are under development right now.
I don't know. I think clearly there are efficiencies of the car sharing that are appealing and attractive to users and to business models. But the United States is a very different place than more compact areas. And for at least a long time, there are going to be people who are accustomed to individual car ownership. And if the cost of making a car fully autonomous is low enough, I don't think we should discount the possibility that there will still be a long future history. That's not a thing. There'll be a long tail of individual car ownership. But I think in the short term, especially when the autonomous cars are expensive and you get the economies of scale of multiplexing that vehicle over a large amount of traffic, that's probably where we'll see the technology first. I just don't know how the ratio will break down.
Just to add to this, I think that the best-selling vehicle, I think, for quite a few years has been F-150, at least and the majority of people who buy it in the US are the contractors. And so you could imagine that they could also be users of autonomous vehicle technology.
Well, is there any specific reason why the distribution should be any different than now? I mean, again, this is a question that you could have asked in the start off cars or buses being produced, and somebody may have asked, you know, in the future, is there going to be just pure buses, or will there be individually owned cars or taxis or so on? That's distribution. I don't think that there will be hard and fast. One can make hard and fast rules. Different parts of the world, different things become popular due to social trends, finances, historical trends. I don't see any compelling reason that one or the other will win out.
Oh, yeah.
Actually, a couple of the trends that were shown earlier by Professor Kowalowski indicate that perhaps there's going to be changes in distribution, but if more people are moving to the cities and cities are more crowded, maybe that sort of, again, nudges toward having more taxis and less private cars. Also, if the population is getting older and older, again, maybe these are people who prefer not to drive. So I think actually some of these trends may change these distributions.
And
so
if the
there are-
expense is a lot higher also, as you said.
Yeah.
Yeah, I'm not arguing that ride sharing and shared cars are.
No, I was commenting to your colleague comments of what might change the distribution versus what it is today.
Well, I mean, certainly the elderly and those who have mobility problems will start using whatever is going to become available, especially if the financial aspects are somehow taken care of. But overall, the human being's choice, I think, will still keep on having a whole spectrum of possibilities.
I completely agree with that. In terms of like diversity, people just prefer different things, and in general, like the shared vehicles helps a lot with a number of things. Congestion is one of them that I think people will care about, but many other things as well. And it's just that like a taxi service is nice. You know, many of you may actually prefer it, kind of just sitting inside a vehicle of your own and being taken somewhere. So that could be some people's choice, but I just cannot see how it could completely eliminate personal cars. I mean, many of you may own cars, some of you may own really nice cars, and it's just, cars may become more autonomous. It could be fully autonomous too, but you may still want to own one. They say it's the ultimate personal device, right? If Apple were to make one, would you not buy it, kind of thing? Apple may be making one, but yeah.
It's also possible that somehow the emergence of new mobility solutions could affect those trends. So it is conceivable that if there are autonomous vehicles that allow easy commute, at least to outskirts of the city, people may choose to live longer, maybe even live in their car, I don't know.
And congestion is a tricky subject too. Thousands of these little Google pods going 25 miles per hour down El Camino Real is not doing anybody a favor in terms of congestion. Yeah. So there's this short-term transient where the technology of these slow-moving cars that are capable of being autonomous might actually exacerbate the problem. Mm-hmm. Beyond that, if you look at companies like Zipcar, one of their major costs is parking. But the good side of that is that the cars that aren't in use, that aren't actively being ridden, are not on the streets. Uber and ride-sharing services basically use our roadway system as a parking lot. And so there's a social cost to having that live load of unoccupied cars waiting for a ride, and that adds to congestion as well. So the how it's going to work out is complicated.
So maybe we could go on to discussing the infrastructure that's going to be required. Like, what are maybe the key points which are going to require really societal-wide acceptance to make happen? Some of the technologies I could see maybe we can operate on in a laboratory. Some of them, it seems like, are going to require agreement maybe with government or. So, for instance, there's a lot of, in intelligent transportation systems, there's a lot of reliance on V to X type communication to solve these problems. And it seems to me that in the long run, is that absolutely necessary to get to the kind of autonomy where you want to put your child in the car by themselves?
I think the communication portion is going to be necessary, is necessary now to provide the request for service, if nothing else. If nothing else. And certainly as far as safety aspects go, a different level of communication, faster data transmittal, is probably going to be absolutely needed. The thing that I'm wondering about is electrical vehicles and the charging issues. There is lots of background work going on as far as both charging on the go, passing over charging stations as you go. Don't know how that will develop. It certainly is conceivable that it will become more usable. Certainly having electrical vehicles charged throughout the day from solar and wind while you're sitting in your office in huge parking lots and plugging in. And again, this technology is here. Whether it will find wide use, I don't know. Probably it will. So those are the two things, both the power supply part. The power supply part, I think we'll see in the next 5-6 years. We won't wait for 20 years for that one. We'll see where it's going. Communication is absolutely, I think, is necessary.
I'm not so I have a complicated view on V2X. I don't think that V2V in particular is could or really should factor into critical safety systems for autonomous cars. One sort of extreme position that you sometimes hear is that the cars barely need sensors at all. They just need a radio, and they'll just all talk to each other and coordinate. But between the security and the inability for us to guarantee a minimum quality of service between cars, whether we reserve the spectrum or not, how do you guarantee that you're going to receive the critical message when you need to? I think there's actually an interesting societal question. We've got this huge chunk of precious spectrum that we have reserved for DSRC radios, and I think we could ask legitimately, if that can't be used to save lives, and I don't think so, would it achieve a greater social and economic good to allow it to be used for cell phone networks?
TV shows?
To release it back.
To TV shows?
To TV shows, maybe. I don't know about TV shows. But I do think that the V2X can be used effectively for optimizing traffic. So, intersection management, intersection coordination, dealing with pollution. If you've got an 18-wheeler that's coming down the middle of your town because it's making a delivery, every time it comes to a stop and has to reaccelerate, there's just a gigantic plume of disastrous chemicals that come out of it. There's a social good there, even aside from speed and efficiency, of just keeping that truck rolling so it doesn't belch its bile in your backyard. And some sort of intelligent traffic management system that isn't safety critical but optimizes the flow could be good there. But I think the other flip side is I think these are times when we're not investing heavily in infrastructure. And so I think they're going to be really challenging questions for what's the best way to spend our dollars. For example, one of the leading causes of single car crashes in the United States is road departure. Single car all by itself, leaves the roadway, flips upside down, kills the driver. In Japan, it's not a leading cause. And the main reason is that in Japan, you've got guardrails almost everywhere. So if someone leaves the roadway, they bounce off the guardrail, they don't get as badly hurt. What's that? Well, But the point being that if we're making hard choices, and of course I love to build high-tech cars, but I think you'd have to ask the question, would we be better investing X dollars in fancy V2V systems or spending those dollars on guardrails?
I think just to maybe add a little bit to that conversation, I think V2X is needed, but how it's going to work, it's not entirely clear because, for example, right now V2I is not under control of the companies that produce vehicles, and it's even sometimes not clear who owns the infrastructure. So you would like to communicate to traffic light, but who is really responsible for maintaining the other side? It's sometimes not clear. So those questions have to be addressed systematically. Yeah.
So I understand your argument that you would hesitate to rely on V2V or V2X, but do you think that it's not going to play a role in 20 years?
No. I think the optimization opportunities, if we're willing to make the investment, could pay huge dividends in terms of efficiency, fuel economy, pollution control, et cetera. I don't see a huge role for safety because of the quality of service. There are regularly stories about someone who didn't want someone to use their cell phone and turned on a cell phone jammer, or who's driving a hazmat truck with one of the GPS tracking things on the roof, and they wanted to go and do something that they didn't want their boss to know about, so they plug in a $5 GPS jammer. It drops out the tracking system, but it also kills GPS reception for everyone around them. This is not a hypothetical thing. It's not malicious. He's not trying to mess up all of the navigation systems of all the cars around them. But imagine that someone similarly motivated did such a thing when you've got cars relying on GPS or DSRC radios for safety-critical applications. I just don't see how to get around that problem. It's too easy to defeat a radio system, deliberately, maliciously, or due to some other reason.
So what are the technology problems that are limiting us today then? Why aren't we already driving autonomous cars around? What are the hard ones to solve?
We'll give someone else a chance.
I said before, it's the human beings around you driving the other cars is the main thing that I'm scared of.
Uh-huh.
I also think that there are many things that are, like Ed said earlier, it's not an easy problem, and largely because of its complexity. I mean, you think about it. You look at the papers, you look at the field. It kind of makes sense. Then you sit down and you start to do it, and you realize it's just the software, even the hardware, just kind of keeps growing to be able to make these things work. To the point where if you go to like some of these companies, like Google, for example, and you look at their kind of computers, like they're running supercomputers on these cars, and they're talking about how much power the computer consumes. It's just kind of crazy when you put all these things together. And even that is not perfect. I don't think you would put that on the road. So there's some technical challenges already to be able to do kind of autonomous vehicles on the public roads that exist today. There are some opportunities still. Like one of the opportunities is actually making cars safer. I completely believe in that. The kind of technology that we have today could completely, I mean, you look at the kind of like 90% of the accidents are like 5 cases. You could try to work on them and just make cars much safer. And in terms of autonomous vehicles, it's just that, I usually kind of put it on a slide. I often talk about there are 2 things that makes it kind of harder. One of them you can think of like the speed of the cars and the around you and your own car or your own vehicle, and the complexity of the environment. As these things increase, it's just the problem becomes harder. There are low speed, low complexity environments like a farm that an autonomous vehicle is so common nowadays. Like you just cannot buy a non-autonomous one. But then as you increase speed and complexity, then you run into challenges. You can limit speed or you can limit complexity. You can create some value. Like you can think about low speed, high complexity spaces where you're going very slow and you can do some things. Or there are even high speed, low complex like highway. You can go on a highway and try to do something. Yet again, I feel like, the moment you go beyond sort of medium complexity, medium speed, safety will be an issue, I feel like. like I said earlier, there may be two futures that we may be looking at. There may be places that just to be on the forefront of this could try to implement things undermining safety. Like you can see sort of city-states trying to catch up with the Silicon Valley and just opening up their streets to autonomous cars, like companies that can come in and deploy. Or you may end up in a future where, just like the aircraft industry, you need to certify things and so on, in which case they would take a lot of time. And I think people are right. I mean, like just this V2X type technologies, when you think about it, we use them in aircraft for safety. We do. But then you don't, like, it's kind of hard to clutter that environment somehow, like when airplanes are, although people are nowadays flying their drones up in the air and just kind of getting into it. But it's just, I feel like this kind of fully autonomous vehicles on public roads kind of thing, it's just a technically hard problem to begin with, and there's so many other issues. Only if you constrain it with some infrastructure, or maybe you work on some other problem, like making cars safer and so on. Those are within reach in the next 5 years, 10 years, in my opinion.
I mean, I've been involved in designing and testing autonomous cars for over 20 years, as I said, and through those years, we had lots of incidents. I can have a whole list of incidents that have happened, not accidents, that's where, barely avoided a crash or whatever. And they were always sort of, we never know the things that we don't know.
Yeah.
And events that will happen that were not necessarily in the group of things that you considered in your design. I mean, all sorts of things from, windy day, newspapers thrown by wind across the highway, slapping on all of your sensors. How often does that happen? Well, once. And there somebody going and repainting all the white fences along the roadway when you have kind of tuned your vision algorithm to a certain contrast. How often does it happen? Well, not very often, but it happens once. And each time one of these things that you hadn't designed for or hadn't included in your robustness analysis and design cases can create problems. So there are still a lot of things like that we don't know.
I think one other technical challenge is the human factors side. So there's an appealing roadmap where you imagine that you could kind of rate a car in terms of how long can you go between having to intervene, to grab the steering wheel and take over. And right now you can buy a car with lane keeping assist, and that measure, that car might score 2 or 3 minutes. And you can imagine a technology roadmap where we keep pushing the mean time between intervention farther and farther down the x-axis, yeah? And eventually, once it reaches 100,000 hours, maybe we call that level 4 autonomous, put your kid in the car, and it's good enough. And the problem with this is that the technology can't actually evolve this way because of the humans. The problem is that once the car is autonomous for periods of time, maybe it's 20 minutes, or maybe it's an hour, or maybe it's every third Tuesday, there's a no man's land for autonomous cars, where that if the car only needs to be, only requires an intervention, every 300 hours, then you can basically guarantee from the human factors perspective that the human won't be ready to intervene when it's necessary. One of the thought experiments that I find really sort of scary is imagine that we have a new car with a new autonomous driving mode. And let's suppose that it drives 10 million miles between serious incident. That sounds really good, right? That means that I've never seen the machine malfunction, and it means that nobody in this room has ever seen this car misbehave. But nonetheless, because if you deployed that technology fleet-wide, that's an order of magnitude worse than a human driver. And so you would see total traffic fatalities go from 30,000 to 300,000 per year in the United States. That's a total disaster. And so there's sort of saving grace of like the Tesla autopilot system, which sort of kind of works. If it worked an order of magnitude better, it'd probably be a total disaster. That'd be my speculation, because people would at that point realize would not be ready. Right now, use the Tesla autopilot or any of these systems, you pretty quickly get trained that you better pay attention, because at any moment it might turn you into the oncoming traffic lane, and so that keeps the human ready to go. And you call it 1% as often, and now that means more people sleeping at the wheel, and then when something bad happens, the human's not ready, and there's a bad event.
This is sobering when our experts tell us.
I can switch to optimism mode here any moment here.
Try that later.
This guy's arm's going to fall off. I feel bad for him.
We're just looking for work.
Hello? Oh, there we go. My question is from these panel of experts here. How long will it be? I have my commute to work is half on the highway and half in the city. So how long will it be before I can take a nap on the highway? And how long before I can take a nap for the whole trip to work? Safely and legally.
So I think you've actually decomposed the problem exactly right. So I think the sort of NHTSA level 4 thing is one-dimensional, right? How autonomous is the car? You can't treat it as a one-dimensional axis. It's really got to have 2 dimensions, and that's what you were talking about. The scenario. You imagine that your car is actually more like playing bingo, right? That you've got the freeway driving, you've got urban driving, you've got the boulevard, and you've got night driving, you've got foul weather. And in each one of those cells, you get to put level 2, level 3, level 4. So I would encourage you all to think in those terms. Now, to put dates on those, I think fully autonomous level 4, you can take a nap and the vehicle will wake you up, a minute and a half before it's time to take over again. Plenty of time. That's probably one of the first things that we're going to see, because it's a high speed, but it's relatively constrained. Maybe it's parking out in the right lane and not going all that fast. I'm hesitant to put a time on it, because one of the challenges we face right now is that even if we had the technology now, it wouldn't make it into a production vehicle for 4 years or something like that. But I think it's reasonable that you would see something like that in a production car in a decade. Wild numbers. Fully autonomous, where it can handle anything that a human driver can do, and that means your bingo board is filled with 4s. Boy, I'd love to hope that we're doing that in 20 years from now, but boy, that's a lot. That's a lot for the system to do, and humans bring so much knowledge and intelligence to the problem that the cars are not even beginning to do. Was that slightly optimistic?
Anyone else want to put your neck out?
Well, I think that, again, as I stated, new technologies, they have sometimes long adoption cycle, and of course, it's hard to rely sometimes on the past. Automatic transmission is 50 years, airbags 25 years. The first production electric vehicle was Porsche in 1900, so it's over 100 years till the volumes got to cumulative sale volume got to 500,000 of vehicles. So to some extent, the answer to the previous question also depends on how much money are you willing to spend to buy an autonomous vehicle. And I think that maybe if I were to be a little bit more cautious, I agree with Ed's view that at high end you might see exactly the vehicles in that time frame. But I think for mass production, something to replace, say, Camry, I think maybe it's going to be longer.
There was another question. Hi, Dan.
So how do you see the impact of autonomous driving technologies on public transportation? It's a big part of the transportation problem. Currently, private transportation devices, cars, do not necessarily interact very well with public transportation. You use one or the other to commute to work, for example. The question is both in terms of autonomous public vehicles and then coordination with traditional public transportation.
That seems like the role for tricycles, right?
Yeah, maybe. The tricycles is that, so We have a project at MIT, and we've been building autonomous tricycles. It was really motivated actually by not as more like a service, but if you work on autonomous cars, you will realize it's very hard to test. Even people with very deep pockets will have like 50 cars that they're rolling around. So we were thinking if you were to make autonomous tricycles, and we have a partnership with Taiwan to like have a little robot town where we can deploy, it could easily be like 100, put them there. So that's the plan that we've been trying to do. But then later, one realizes that actually autonomous tricycle is not a bad idea. I keep changing my mind every week. Every week I feel like maybe it's not a good idea. Then the other week, then it's good. But sort of to maybe kind of understand the impact on more like public transportation, it's just that it's a matter of, I think, to some degree, it's a matter of investment. And this investment may happen somewhere. It's already, for example, like the recent DoD challenge that I'm sure many in the room, like this panel of experts, have worked on, like myself. Ümit was just saying that the Columbus is also like is chosen as one of the 7 finalists. The challenge was to kind of come up with a proposal to spend $50 million to do something that relates to these kind of technologies, to put them on the cities. And so people will be thinking about these kind of things. It's possible that there's somebody somewhere on Earth that would be willing to put this money to do something interesting. Clearly, some shared transportation comes to mind first. I'm not sure if it's going to be that way, but imagine, like a subway that you take. It's $2 in Boston. It works. It's not completely subsidized, so you pay $2. It's very inefficient. You could have like a taxi-like system if you were to make the infrastructure investment. Not now, but maybe in 10 years. You could pay 99 cents for a ride. You could go anywhere. Every ride would be 99 cents. It'd be great. And if you were to be able to do it. I think maybe some of these things, people may realize that it's a low probability. I'm trying to be optimistic, but it's a low probability event. But somewhere, somebody on Earth may realize that they may want to take this challenge forward. They may want to implement something, and they may make it work. Going back to autonomous tricycles, we've started a collaboration with the city of Andorra. I don't know who heard here where Andorra is. It's a city-state between Spain and France. I'm sure there are a few people who have heard about it. They're probably from Spain, Italy, or France, somewhere that they know about it. But they want to be at the forefront. They want to invest something. In their terms, they want to invest big money to put autonomous tricycles on their streets. Andorra is a small example, but you can imagine places like, Singapore or Netherlands, or and going after these kind of infrastructure projects and just kind of stripping out their subway system and replacing it with like a mobility on demand solution. That could actually happen. Not soon, but that was optimistic enough.
That's an interesting example because it does involve government sponsorship to make that happen. And I think that's one of the
some infrastructure comes out without the government sponsorship. Like when you think about it, we have an amazing, like a cell phone, like a radio infrastructure. Much of it comes privately because we're happy to pay for it. But in this case, kind of it's hard to start it out privately, I think. Again, you never know. Like sometimes people, like for instance, there's this whole Hyperloop thing that's happening. And it is with investor money. Some people are, you all put your money into banks. Those banks take that to VCs, venture capitalists, and venture capitalists take them to a company, and that builds a Hyperloop. Sometimes things like that do happen too. Could happen, yeah.
We'll watch on Hyperloop. I wanted to save a little time at the end, if there's not a question here, because I think the last question in the list here about advice for Mitsubishi Electric and MERL in particular is something I'd really like to get you on record with.
So I would approach it in terms of what do I think is the most interesting research problem to be solved that's relevant to this. And it comes back again to the safety number of 100 million miles per fatality. And suppose I hand you a car, and I say, tell me how good this car is. How do you begin to evaluate how good a car like that is? RAND did a study recently, it was in the press a bunch, And with some undergraduate statistics, they basically said that if you want to show that a car drives at 100 million miles per fatality with 80% confidence, you have to put 8.8 billion miles on that car. And clearly that is not a tenable solution for us to be building and deploying and hopefully producing products that can do this. So I think the real technical challenge here is how do you get the statistical power of 8.8 billion road miles without doing 8.8 billion road miles? And there's a lot of ways of doing it. Simulation can help a little bit. What Rodney Brooks said many years ago, simulation is doomed to succeed. That makes me a little bit.
Still say that.
Yeah.
He still says that. Yeah.
Yeah, it's true. So it's hard to know exactly how to get the simulator. Controlled tests that are designed to be much, much harder than the real world environment, that can be part of the picture. At Michigan, we have M-City, which is that 32-acre test facility. And our notion in our head is that if we make the driving around M-City really, really fiendish, maybe there's an exchange rate. Maybe driving a kilometer on M-City is equivalent to 1,000 road miles. I don't know how to calibrate that. But we need that sort of lever arm to be able to make claims about the safety of these systems. So there's lots going on here. Russ Tedrick has a lot of really cool work that he's doing in terms of trying to validate and formalize these things. But I think that's a really interesting research problem.
Mm-hmm.
Interesting you say. Well, I used to work with a professor who said, the most interesting problem are the ones that I'm working on, obviously. So not being biased. I do think that we need to do research more involving humans, and in two directions. One would be the pedestrians and how they move, especially if we're going to send these vehicles into the depths of the cities. There will be lots of pedestrians walking around them, and how they react and what they do, I think, is something that we'll have to face more than what we have done. The other is the human beings inside the car. And I'm especially due to a center that I'm involved in, which is related to crash imminence. We have to deal with how human beings will reacquire control of the car. And that's a non-trivial problem. All the way from teenagers looking at their iPhones and then looking back up, and how long does it take for them to understand what's going on, especially if the car is going to turn it back to them saying, hey, I can't do it, it's all yours, which is the expected thing right now. So that in a general sense, how long will it take for humans to reacquire and understand the safety issues and understand that what they could be doing? And also what human drivers may be doing that is hard to understand. How much can you rely on the signs given by human drivers, like human drivers who are in a left turn lane? Will they turn left? Or human drivers who may give you a gap for your car to merge into. Will they keep that gap, or just for spite accelerate to make the gap shorter for you just when your automated car decides to do a lane change?
And as a function of whether you're in Boston or Ann Arbor.
Very true, very true. So there's a whole series of things related to human that I feel has to be addressed.
So what to do for MERL? So MERL has been, contributing very immensely on the technology side of things, like perception. You've seen many posters out there today, like from image segmentation to visual odometry and so on, and we need that. I think it'd be great to emphasize that, and it'd be great to emphasize how MERL's contribution had been so important. But to add to some of that, there's the human component to it. I would take that one step further and actually talk about the social component. So it is at the end, this whole mobility is going to affect the social system. So I think it's good to take a step back and think about really what is it that people would need rather than sort of putting X and Y together and creating something new. There's a lot of emphasis nowadays today saying that, okay, we have robots, we have cars, why don't we put them together? Sometimes that works. Like in the past, we've done things like we had a horse carriage, we took the horse out, put the engine inside, and we kind of just kept optimizing it, and we got the cars that we have today, and it works great. We own them. But there's some other technologies out there that people really think about the social component better, and people understand sort of what really is needed, and it becomes a big business that helps a lot. Some of you may not like it, but maybe like Ubers or Lyfts of today will become that. So it'd be great to think a little bit more about the sort of social components of things, especially now that we have this abundance of data that we can kind of look through and try to understand as a society, what is it that we want and need.
Perhaps just to add two things to the previous remarks. I think, as Professor Asgurna mentioned, there is an uncertainty component in being able to make the decision. So some techniques for making decisions under uncertainty, and it's not just the human drivers, but it's also even when you get data from the sensors, whether an object is there or not, there is a certain probability. That's what you see in the object list that you read off. And so how to make sort of decisions over some horizon, but then taking into account uncertainty I think is a good problem to work on. And that points to developments in model predictive control here, but perhaps expanded to somewhat uncertain scenario handling. The other area that I want to mention is that is the fact that clearly there will be a lot of data collected from vehicles, and in particular if the vehicles become autonomous, there will be some kind of black boxes on board so that you can at least figure out what went wrong. So if you imagine that you have terabytes of data and maybe even higher numbers of those, how do we effectively look for things in those data sets? So I think technologies that allow you to work with massive amounts of data, form queries, get information out that you want. I think this is also an area that's going to be perhaps be important. And then finally, perhaps thinking a little bit about what future infrastructure might look like in terms of servicing vehicles. So, for example, if vehicles are shared, how they're going to be serviced. How they should be designed. Perhaps the emphasis will be given strongly to durability and even reliability of those vehicles. We don't know who is operating them and how. And perhaps there could be some interesting solutions in that domain, how you monitor vehicles how you do prognostics and decide to schedule some kind of maintenance actions. So I think I promised two. I think I actually mentioned three, but it's okay.
Okay, well, I think we've come to the end of our session, and so I don't see any other questions. Why don't we thank? Oh, I'm sorry, I do see this question.
I got one. If you got a minute.
Yeah, we have a minute.
So, in general, I share the more pessimistic view that this level 4 autonomy across the board, any situation, is something that's quite a number of years away. But I do kind of also recognize that we have made considerable advancements in the last 10 years for technologies that have definitely improved the experience. My example is I just got a newer car that has adaptive cruise with automatic braking and stuff. And once I've driven that, I don't think I'm gonna. That's definitely high on my checkbox for the next car I'm gonna buy, because I think it makes my experience better. It makes me a safer driver overall. I like it. So if I make it a little bit more real, more short term, what do you think kind of the next you know, the 5 year out, not this full autonomous thing, but what do you see as kind of like, hey, the industry really should look at whatever, pedestrian detection is kind of the next thing out there that seems more reasonable, more realistic, something that in 5 years we could roll out a solution that makes an impact?
The pipeline actually looks really good in terms of even things that the tier ones are already working on and that are on roadmaps for vehicles. I'm going to twist your question just a little bit and almost put this back into advice to Mitsubishi Electric, is that there's a huge amount of pressure for every automaker to advertise their level 4 vehicle. And a lot of these component technologies, which make us safer drivers in an ADAS application, can be turned into an autonomous system as well. But the choice is not quite that simple. They can make it a really effective ADAS system, one where we feel safer and we are safer, or they can be turned into a subpar, underperforming autonomous system. And I think the one thing that I'm most worried about from the business atmosphere is that the pressure to develop a level 4 autonomous car to keep up with all of the other competitors who everyone imagines is so far ahead of where you are, but they aren't, that automakers will start creating level 4 vehicles that are actually worse than what we have now, and certainly worse than what we could achieve by deploying these ADAS systems to make a driver a better driver. There's no certification process to call yourself a level 4 car. Maybe I misunderstood the question.
Here's the question.
Yeah, just opening yourself up to lawsuits. It's a liability issue. Yeah, I'd rather see in the short term us deploy a better forward collision warning system as a driver assistance feature than as a slightly better Tesla autopilot. Because I think the bar for us to achieve the level 4 is much higher than the public perception. Anyone want to actually answer his question? I kind of.
No, you're fine.
You've been good.
All right, well, let's thank our panelists.